Hello, my darlings. Okay, so today we're going to look at more area between curves, but this time we're going to use horizontal strips. What does that mean? Well, here we want to find the area between the curve and the y-axis. We haven't done this before. So what we say is that the area is the integral from c to d of the function in terms of y, dy. And it's the sum of each area of these horizontal strips, where the change there is dy, just like delta y, okay? And these are the horizontal strips. So it's just like when we did with the x's, only now everything's going to be in terms of y. Why would we want to do something like that? Well, look at this example. Find the area bounded by x equals 8 plus 2y minus y squared, the y-axis, and the lines y equals -1 and y equals 3. Do you really want to solve that equation for y? You're not going to be able to get that in terms of x. That's why we sometimes find the area with respect to y. Okay, so let's see what this picture looks like. Let's do the easy parts first. So we have a line at y equals 1, and we have a line at y equals 3. And now we have to graph this x equals 8 plus 2y minus y squared. Okay, so to graph this, the axis of symmetry is -b over 2a, which would be a -2 over a 2 times -1, which is y equals 1. So the axis of symmetry is 1, so if we substitute in the 1, we would have 8 plus 2 minus 1, that's 9. So our turning point is here. Now remember the shape of a parabola: over 1, up 1, in both directions, over 1, up 1, 2, 3. Oh, look at that. That'll give us enough of our curve. And yes, we know it keeps going, but we don't need that. So the area we're looking for is in here. Okay. So instead of doing this in terms of x now, we're going to do this in terms of y. So the area is the integral. Now the y's go from -1 up to 3. And our function in terms of y is 8 plus 2y minus y squared dy. And now we're going to take the antiderivative. Antiderivative of 8 is 8y. Antiderivative of 2y is y squared, minus antiderivative of y squared is y cubed over 3, evaluated from -1 to 3. We substitute the 3 in first. 8 times 3 is 24, minus 3 squared is 9, minus 3 cubed divided by 3 is 3 squared, which is 9, minus, open parentheses, 8 times a -1 is -8. -1 squared is a +1. -1 cubed is a -1. So 2 negatives make a positive, 1/3. Then combining terms here, we're going to have 31 minus 1/3. Now 31 would be 93/3 minus 1/3. 92/3 is our answer. That is the area of that green shaded region. Awesome. Now, what if we want to find the area between two curves? Okay, and sometimes we have to do this in terms of y. So the way we do this, it's the integral from c to d of, now in this picture, f of y is bigger than g of y. So we take f of y minus g of y dy. So the area using horizontal strips, meaning we're going this way, okay, we're going to do the integral from c to d of the curve on the right minus the curve on the left with respect to y. Okay, let's try an example. We're going to find the area bounded by x equals 4 and x equals y squared. So x equals 4, that's easy to graph. There we go. And x equals y squared, that opens to the right. Over 1, up 1, over 1, up 1, 2, 3. Nice. Now we have a nice sideways parabola. And and we're looking for this area in here. Now, important to remember, the limits depend on y. Okay, so the y's are going from -2 up to +2. So this is the integral from -2 to 2 of the curve on the right is x equals 4 minus the curve on the left is x equals y squared, and this was with respect to y. So we take the antiderivative of 4 is 4y minus the antiderivative of y squared is y cubed over 3, evaluated from -2 to 2. And yes, you could also have done symmetry, 2 times the integral from 0 to 2 of 4 minus y squared dy, because there is an axis of symmetry here, all right? And yes, that would be the same, okay? Either way, it doesn't matter. So now we substitute. Our top here is 4 times 2 is 8 minus 8/3 minus, now we plug in the -2, we're going to get -8 plus 8/3. So we're going to have 8 plus 8 is 16. -8/3 minus 8/3 is minus 16/3. So we need a denominator of 3. 16 times 3 is 48. And 48 minus 16 is 32, and our denominator is 3. And we have found the area. Okay, next problem. Find the area bounded by the graphs of y equals x cubed and x equals y squared minus 2. Okay, now yes, this is a calculator problem, but in order to put it in the calculator, you have to look at this x squared equals y squared minus 2 and realize that that's y squared equals x plus 2, and y is a positive and negative square root of x minus 2. So that's going to take two functions in the calculator. Okay, so let's take a moment and graph it. Okay, so here we are. First thing we're going to do is put in the function y equals x raised to the third. Then we're going to put in the function. Now remember, this x equals y squared minus 2 had to be put in as two functions. So we have the square root of x plus 2. And then we have the negation of the square root of x plus 2. Okay, I'm going to move my labels a little bit. I'm going to find the points of intersection. We have to tell it which graphs we're finding the intersections of. Now we'll do for the other pair down here, and there we go. So we have that our graphs are intersecting at the point -1, -1, and at this weird point at 1.21, 1.79. And I bet if we control menu and hit attributes, there are more than 2 digits there. Okay, so remember, you always have to check that. That means those are rounded, and we cannot use the rounded values in our integrals. Now here's the thing. Are we going to integrate with respect to x or respect to y? If we use the vertical strips and integrate with respect to x, the top function is always this square root of x plus 2. However, the bottom function is first the negation of the square root of x plus 2, and then it's x cubed. We would need 2 integrals. If, however, we integrate with respect to y, this x cubed is always the function on the right. And this parabola is always the function on the left. And if we use it in terms of y, it's only one equation. So it makes sense to do this in terms of y. So let's find our y values then are going from -1 up to this 1.793. So we're going to point at it, control menu, and we're going to store, let's call that B, and hit enter. I'm going to go to the calculator page. So I'm adding a page, it's calculator. I'm going to type B. That number, that whole long number has to be written out. Okay, so now we're going to use the integral, and we get our definite integral. Y's go from -1, tab up to our b, tab over, and our function is y raised to the 1/3 minus the function y squared minus 2, tab dy. Okay, so we decided we're going to use the horizontal method because we'd only need one integral. So we're working in terms of y, which means we have the integral. Our y's go from -1 up to b, and we make sure you have this written down so they know when they're grading your AP what that is. Now our curve on the right is y equals x cubed. However, that's not in terms of y. So to solve for x, we would have to take the cubed root of y or raise y to the 1/3. So our function on the right is y to the 1/3 minus, and then our function on the left is y squared in parentheses minus 2, so that we remember to distribute that. And we put that in our calculator, and we get 4.215. All right, my darlings, there we go. Have a great day. See you soon. Bye.